Hi, and welcome back to another maths video. In this video, I'll be covering inequalities. So what is an inequality? Well, as the name suggests, it's something that's not equal to something else. Instead, it's either greater than, less than, greater than or equal to, or less than or equal to something else. So if I had x is less than 6, x could be, anything less than 6. It could be 5, 4, 3, minus 1,000. For y is greater than or equal to minus 3, it could be, again, greater than or equal to minus 3. So it could be minus 3, minus 2, a million, 2 million. But in this, this is two separate inequalities put together. So x has to be greater than or equal to minus 2, and at the same time, less than 1. And for this, there's like a specific range that x could be. So it could be minus 2, minus 1, or 0. It can't be anything else apart from these three. In GCSE, you might be asked to show an inequality on a number line. The question could show you something like this, and ask you to state what inequality is shown. The main thing you need to remember is that a hollow circle means either greater than or less than. And in this case, because the arrow is pointing to the right, we can tell that the inequality has to be greater than minus 2. So we can write it out as x is greater than minus 2. However, if I was to make the circle full, like this, it would mean either greater than or equal to, or less than or equal to. So in this case, because I filled the circle out, it would be now x is greater than or equal to minus 2. In this case, we're asked to draw the inequality x is less than or equal to 4. So again, we need to remember that because it's less than or equal to, we need to have a filled in circle, and obviously at the point 4. So let's do that. Circle, fill it in, and then we need to draw a line pointing to everything less than 4. And that's it, that's our inequality drawn. You might also be given something like this. It looks a bit harder, but it's pretty much just two inequalities instead of one. So the first inequality tells us that x has to be greater than minus 1, right? Because the circle is hollow. The second inequality tells us that x also has to be less than or equal to 4. So let's write that inequality out. So the way we'd write it is this. Because x has to be greater than minus 1, but also at the same time less than or equal to 4. So we have to put it in the middle, between the two extremes. Now let's look at solving inequalities. To solve an inequality, all you have to do is assume the inequality is in equals and solve like you normally would. And at the end, you just have to remember to swap the equals back with the inequality. So for example, we have 2x plus 5 is greater than 15. So first, we need to swap the inequality with an equals. So 2x plus 5 is equal to 15. And then from there, just solve like you normally would. So let's subtract 5 from both sides. We get 2x is equal to 15 minus 5, which is 10. Then we divide both sides by 2, which is x is equal to 10 divided by 2, 5. And at the end, we need to remember to swap the equals back with the inequality. So we, instead of x equals 5, we get x is greater than 5. So x can be any value greater than 5. However, there is one rule you have to remember. If you divide or multiply by a negative at any time when you're solving, you have to flip the inequality at the end. So let's take an example. We have minus 3x over 4 is less than or equal to 3. So let's do exactly what we did here. Let's assume that this inequality is in equals and solve from there. So we get minus 3x over 4 is equal to 3. So let's multiply both sides by 4. We get minus 3x is equal to 3 times 4, which is 12. And now we're dividing both sides by minus 3, which is obviously a negative. So let's do that. We get x is equal to minus 4. And let's replace the equals with the inequality. So x is less than or equal to minus 4. But remember, because we divided by a negative, we need to flip this inequality. So instead, it becomes x is greater than or equal to minus 4. And that is our answer. One final question you might be asked is to solve an inequality with two signs. So how do we do that? Well, again, the main purpose of this is to get x, the variable, on its own. And so whatever you need to do to get x on its own, so in this case we need to subtract 1 from this, we need to do to both sides of the inequality. So let's subtract 1 from here, and we need to do this here as well as here. So we're left with 3 minus 1, which is 2, is less than x on its own, which is less than or equal to 7 minus 1, which is 6. So this is our final answer. Let's now move on to graphing inequalities. The main point of graphing an inequality is to shade an area that the inequality satisfies. So basically, the area that the inequality is. Let's look at an example. So here, we're asked to indicate the region that satisfies x is less than 3. So to graph an inequality, we basically have to do the same thing we did when we solved it, which is to imagine the sign as an equals, and draw the line we made from there. So in this case, instead of x is less than 3, we get x is equal to 3. And that line is this, right? Because along that line, every value of x is equal to 3. Here's where the inequality part comes. So remember when we drew an inequality on a number line, where a hollow circle meant either less than or greater than, and a filled-in circle meant either greater than or equal to, or less than or equal to? Well, in the same way, when we're drawing an inequality on a graph, less than or greater than is shown by a dotted line, and a less than or equal to or greater than or equal to is shown by a solid line. So in this case, because it's x is less than 3, and our line is this for x is equal to 3, the line needs to be dotted. So this is our inequality, x is less than 3. But we're not done, because we still need to shade the region that satisfies x is less than 3. So how are we going to do that? Well, what I do is I take any random point on the graph and see whether it fits the inequality. So for example, let's take the point 0, 0. The x-coordinate of 0, 0 is obviously 0, and so let's put that into the inequality. So is 0 less than 3? Well, yeah, it is. So we know that that point satisfies the inequality. Let's take another point, say 5, 3, here. Again, we put that into the inequality. Now, is 5 less than 3? Well, no, it's not. So, from that, we can tell that anything on the left side of the graph fits the inequality. So let's take another point, just to keep you satisfied. So minus 2, 2, that point. So the x-coordinate is minus 2. Is minus 2 less than 3? Well, yeah, it is. So again, we know that so all of this left side of the graph has to fit the inequality. So for the final part of your answer, all you need to do is just shade this left side to indicate the region that satisfies the inequality. And boom, you're done. Let's take a harder example. So here we're asked to indicate the region that satisfies 2x plus 1 is greater than y. So we can rewrite this as y is less than 2x plus 1. And that makes it seem more of like a linear equation. So just do what we did last time. So we can rewrite this as y is equal to 2x plus 1. And we can draw that line. If you remember how to draw a line, you can skip this part. If not, let's quickly go over it. So the first part that we need to remember is the number next to the x. This is the slope and tells you how steep the line is. The second part is the y-intercept, and this is where the line crosses the y-axis. So, because it's a 1, we know that the line has to pass through this point right here. Let's move back to the slope. Because the slope is 2, we know we need to go up 2 and to the right 1. And using those pieces of information, we can draw our line. By the way, if you want a more detailed video on drawing a linear equation, let me know in the comments, and I'll try and make one. But wait, this isn't a linear equation, it's an inequality. So we need to remember to either dot the line or make it solid. And in this case, because the inequality is a less than, we need to make it dotted. So here we have our dotted line that represents the inequality, y is less than 2x plus 1. But now, we need to indicate the region that satisfies the inequality. So let's do that. Again, we'd basically use the same method we did last time. Just select a random point. So let's do the point 3, 1. So the y coordinate of that is 1. So let's put that in. So 1 has to be less than 2 times x. X is 3, so that's 3 times 2, which is 6, plus 1. So is 1 less than 6 plus 1, which is 7? Well, yeah, it is. So from that, we can automatically tell that everything on the right side of the line has to fit the inequality. So immediately, we can shade all of this in, and that's it. We have our answer. But just for your satisfaction, we can double check. So let's do the point minus 2, 4. So the y coordinate is 4. So 4 is less than 2 times minus 2, which is minus 4, plus 1. So is 4 less than minus 4 plus 1, which is minus 3? Well, no, it's not. It's bigger than it. So this side of the equation, this side of the line, can't satisfy the inequality. So we proved it again. Now, as a side note, a question might ask you to count the number of points within the shaded area. So the main thing you have to remember is that you can't count any points on the dotted line itself. You can count points on a solid line, but not a dotted line. And that's because any of those points aren't actually part of the inequality. Because it's either less than or greater than. It's not less than or equal to, or greater than or equal to. If it was a solid line, because it would be equal to, you could count the points. But you can't if it's a dotted line. So say, for example, we had a dotted line like this, a solid line like this, and another dotted line here. You could count all the points. So you could count that point, that point, that point, this point here, but none of the other points, because they all lie on a dotted line. Right? So the total number of points would be 1, 2, 3, 4. So thanks for watching. If you like the video, please do like and subscribe. And if you want to see a video on graphing linear equations, please do let me know in the comments. Thanks, and I'll see you in the next one.